Good morning and good afternoon. Thanks for joining in. We welcome you to today's Office Hour session. I'm Manan Sethi and I manage Global Developer Relations at EMQ. I'll be your host for the informative and engaging discussion that we are going to have today. So before we dive into the agenda, I'd like to share a few quick pointers around today's session. So firstly, please consider me or treat me as your point of contact for any queries that you have, any additional information that you require from us. I'll be happy to assist you with your queries or get the relevant stakeholders involved to help with your queries. Feel free to type in your questions in the chat or in the Q&A tab throughout the presentation. We will address them during the Q&A session or right after each session as time permits. We want to make these sessions quite engaging. So we are also interested in hearing from you about the use cases that you're using EMQ for, or you are planning to use EMQ for, any challenges, any successes in the IoT space that you currently have. We have a packed agenda for today. We are featuring some exciting topics. We have some expert speakers today. So let's make the most of the time together. So let's start today's session. Let me quickly walk you through the agenda. We have divided it into main four aspects or smaller sections. We are going to talk about software-defined vehicles. It represents a cutting-edge innovation in the IoT landscape, transforming traditional vehicles into dynamic, upgradable platforms. So by leveraging open source solutions and advanced connectivity, SDVs enable seamless integrations and new features and updates, enhancing vehicle performance and as well as user experience. So this approach is revolutionizing the automotive industry and is driving advancements in the autonomous driving space, predictive maintenance, and also personalized in-car services. From our expert today, we are going to learn about SDV applications, the industry trends, challenges which are there, and what solutions EMQ is building around SDV and its use cases. So it's quite an interesting session to start off with. In the second session, we have an exciting product demo lined up. It is a step-by-step procedural, showcase that will help us thoroughly understand EMQ's offerings. In our last session, if you remember, we discussed about EMQX serverless, and today we are going to delve into the data integration part with EMQ serverless. This hands-on demonstration will provide valuable insights to us, and also how can you use EMQ solutions to enhance your own IoT solutions. In this endeavor, we are also building product demo videos, which we have been sharing with you quite some while. We will also host them on our YouTube channel and our developer channels separately. Thirdly, the third session would include the product update session. This has been a consistent session with us, wherein we talk about the latest developments and enhancements to our offerings. This segment will also offer valuable insights into advancements that we have made, with our solutions. We have also a demo to see the latest features and add-ons. So we have included it this time, that rather than just talking about the features with you, we'll showcase it to you right there and then. And towards the conclusion of our session, we'll welcome your questions as usual, whether they pertain to our product, industry trends, or any other topic. We are here to offer clarity. We are also eager to learn about your experiences with EMQ products, how you're currently using your product as mentioned. If so, in what scenarios, use cases, if you're considering EMQ products in the future. So what specific purposes are you exploring for? So without further ado, let me introduce Jalen. Jalen Yu, who will give us insights into the STV landscape so far. Jalen is an open source enthusiast and a versatile startup professional. Jalen also holds several IoT patents, not to mention, with over 10 years of experience in IoT and edge computing. Jalen is passionate about integrating software and hardware in the IoT, IOV, and SDV fields. Currently, Jalen serves as the Solution Vice President of Edge Computing and initiator of the Nano MQ project at EMQ. So without wasting any time, over to you, Jalen.
Oh, thank you, Manan. Hi, everyone. It's my honor to be here. Also, my first time to be the guest to speak at our office hour. I'm pretty excited. So let's dive into the world of vehicle now. let me put on my slide now. So I guess everybody has a driving experience before. The SDV, or in the full terms, software-defined vehicles, has a totally different value proposition than that of a traditional vehicles. The car the car you're driving now is no longer being finalized at the very moment once it was manufactured. Now the passengers and the driving experience are no longer determined by mechanical or electrical systems because the software accounts more now. The software capabilities continually improve during the vehicle life cycles. So for the past days, we treat vehicles like a riding tool. It is just a vehicle, a tool for saving our work time. Now, SDV could act as your entrance for the next digital life. It enables a lot of different various features like a smart cockpit. You can enjoy your digital life in the vehicles, and then enjoying like autopilot, auto steering features while you're driving, and you can put your attentions on like on phone calls, on on the communication with your families. Yeah. So that new generation of vehicle, soft-defined vehicles really give us a lot of convenient and a new style of life. And in conclusion, SDV can also be defined in operational terms where a software acts as a brand of the vehicles by enabling the enhanced features and containing critical information such as design parameters, a failure mode event analysis. The features I just took as an example. It's just the most easy to get features. Other features is hidden under the hood. You don't have a direct touch with them, but actually they are build a hidden bridge between the drivers and the OEMs and the manufacturers to provide you a better driving experience. Yeah. So now, like failure mode event analysis, quality fix procedures, and the manufacturing processes. The combination of these data sets enables an SDV to self-diagnostic and correct discrepancies as they emerge. So now you have a basic understanding of how SDV gonna change your vehicles, the way you're driving now. But what on earth actually happens behind it, or what is required? So first part is communications. So any features, if you don't have communication, you don't have new innovations, you cannot enable those incredible and super convenient features. Yeah. So in the past days, the vehicles is communicated by signals. So as you can see from here, the signal is just like analog signals you might have experience with, like a radio meters. Yeah, you listen to the music from radios. Those signals is coming to you as a analog format. So yeah, that's how communication happens in your vehicles in the past days. However, if we wanted to push new features into your vehicles, the analog signal is not enough because it cannot support the high volume of data communications. So we have to move from signal to service. So the first part is we need to map signal to the service. We have here is a roadmap from Bosch. He has Bosch company actually present as a pretty clear roadmap in like 10 days, 1 decade ago. Now we can see actually a lot of a Chinese OEM, new EV brands is already moving from level 2 to the level 3. So basically, is the thing is usually the signal communication is happening between the different ECUs or different microcontrollers. Those microcontrollers communicate with each other while analog signals, and In the second level, or this is the most common you're gonna see in the modern vehicles. We have a domain controller sit on the top of each ECU. This domain controllers can aggregate all ECU the signals from ECUs and convert them to the service, and allows new communication protocols like TCP/IP. Yeah, they communicate while they communicate with the domain controllers to get the data, push the data, ingest the data, and exchange the command, so that users can we can build other new service on top of it. And this level 3, or the new coming architecture is like a central. There is a central computing unit in your vehicles. Yeah, this is how Tesla builds their vehicles, builds their ADAS features. They have a supercomputer in the vehicles, which act as like a human brains. It perceive all the signals and from the ECUs and sensors, and it trains itself, evolves by itself. So basically, yeah, oh, in the road to from the signal to service is one necessary step to take for enabling SDV. So the SOA terms here stands for service-oriented architectures. Uh, it, it is totally different from the past signal-oriented architectures. Yeah, in the signal world, we communicate via CAN bus, via flex array, via link bus, and via another widely used bus is MOST, MOST. Yeah. So basically, yeah, we wanted to enable more functions. We need to separate these ECUs. We need to have a distributed deep domain controllers, and we need to have a next level of interoperability and reuse data streams. Yeah, the terms that sounds familiar with IT world. So actually, this is a trending comes from IT part. We like you might have known the Industrial 4.0. Yeah, so it's a similar story in the vehicles. We bridging the IT technology, open source technology to the vehicles. For decades, yeah, as I told you before, the vehicles have been governed by mechanical engineering concepts and powered by the combustion engines. In the 1970s, like electronic controls units, yeah, stands for ECU, yeah, and I'm gonna just say ECU from now on, yeah. The ECU were introduced to manage different vehicle functions, which yeah, like you have a air conditioner in your vehicles. So actually, you are once you push the button to alter the temperature, the command goes directly to that ECUs while CAN bus signal. Yeah, the ECU were introduced to today. Yeah, the global automotive industry is undergoing to unprecedented transitions. Yeah, one of them is software-defined vehicles. Another is the decarbonizations. So actually, the decarbonization requires SDV as well. Yeah, as you can see, from 1980s to 2025, the industry is struggling or is trying their best to start a lot of new organizations to move from the signal-based service to the service-based service. There is some major organizations such as OSEC. Yeah, this is the previous form of AutoZar. AutoZar is another organization was initiated by the most significant OEMs in the world. They come together and to build another organization, build a new organization to set up the rules, to set up the standards, so that the softwares and the ECUs could be migrated from one card to another. Yeah. The right part here is a diagram shows you the architecture of a zone architecture, of domain architecture, of a new our next generation of essential architecture. Yeah. So a little bit more information about the vehicle here. It's a AutoSAR. Here's a introduction of AutoSAR organization here. And AutoSAR is consisting of two different parts, CP and AP part, adaptive and classicals. Basically, the classical part is still a mechanical world. We only have a microcontroller on it, and we build most simple embedded software on it, because only embedded software can assure you the hard real-time requirements by hard interrupt. Otherwise, software interrupt cannot guarantee the execution sequence and the safety. Yeah. So on the top of AutoSAR CP, we have AutoSAR adaptive platforms. This is where our software lives on. It's actually just like embedded Linux environment, where our edge computing software can easily be migrated to the AutoSAR adaptive platforms. Now we know what is SDV, and now we know and how industry is trying to move to the next stage, but we are still not there yet because we are facing a lot of challenges. Yeah, the Chinese EV brands actually is trying is is a leading party of the SDV trending. And we have a lot of new business case regarding on SDV part in the China market. From our perspective here, we see the major challenge are these three parts. The first part is the SDV faces a challenge by the different requirements, like it considers one is safety criticals. So once we're gonna introduce a lot of new open source software into the vehicles, we have to balance between the functionality and the security and the safety. Yeah, we have to achieve a better security while preserving the most functions. This is one major challenge. Another part is the data interoperabilities. So this is one biggest advantage of EMQ here. And you know, our EMQ is broker enabling millions, even billions of connections, concurrency connections to allow them exchange data in one space, which is called unified namespace. And in the vehicles, you can imagine the same thing, same story here. We got unified namespace in your vehicles, and just with lower network infrastructures with lower bandwidth. We have to squeeze the bandwidth in the max extent to take advantage of each computing power of your vehicles, because the vehicle is not like your cloud infrastructure. You can easily scale them horizontally and scale horizontally. Yeah, you have to make every bit of power counts. Yeah. So in the 1980s, in the 1990s, we only have 70 to 300 MCUs in the vehicles. Nowadays, we gonna get more. We're gonna get a more aggregated ECUs, SoCs, but they are dealing with a huge amount of data, which is have never been seen before in for automotive industries. Yeah, so we're gonna deal with tremendous data volumes in the vehicles. Lots of data volumes gonna be gigabytes per second. Yeah, and but we don't have the same networking tools in the cloud as we have in the cloud. Yeah, but we have to make data flows to enable computations, to enable functions. Yeah. So as I said before, there are different domains and controllers in the vehicles. We got like a high computing power SoCs sits on the body control domain, ADAS domain, and infotainment domains, and they communicate while cables in the vehicles. If we wanted to exchange data in a highest efficient manners, we're gonna uh, we're gonna cause a lot of cables to be deployed in the vehicles. It's gonna make your vehicles a lot of heavier. It is not a good thing for drivers, for the OEM manufacturers. You have, because once the weight once the heavier of your vehicle is, the more petroleum, the more energy you're gonna cost. Yeah, it's not a good thing for decarbonizations. Yeah, so we have to find out a good networking, a good interoperability middleware for exchanging data between domains, between ECUs in an efficient manners. Another challenge or one major motivations of SDV is the project development. As you can see, in the Europe or in the United States, the new type of vehicles is released at like 4 or 5 year cycle. Well, we define a new product, and we put 2 to 3 years on the designing part, and we put another 2 years to integrate all ECUs together and to verify the safety, to verify the functions, to do to meet the regulations, to pass ISO 26262 standards. And then we're gonna cost another 1 year to do the final test, to do the finalization, and to do marketing. Yeah, but however, the penetration of however nowadays the SDV has come, the software becomes a huge amount. It takes a huge amount of development time in the new cars R&D recycling. So in the past, they only have like 1 million, even only 10,000 code line of code in your vehicles, because we are only dealing with the embedded software. Nowadays, it's not. It's 1 million or 10 million lines, even billion lines of in your vehicles. If we gonna have a level 4 autopiloting feature ready in your vehicles, yeah. We all know here, yeah, the software takes even more times to debugging to make it stable. Yeah, the same story in a vehicle. Actually, the case is worse because this is embedded software, and we have to meet the security standards. So one of the penetration of the SDV is positioning night for exponential growth. So as I said before, the security regulation is one major obstacle we need to overcome. The automotive industry has evolved based on a zero fault tolerance in manufacturing vehicles. Yeah, software is often inherently prone to errors and bugs. Yeah, as the amount of software in vehicles increases rapidly, the ability to fix software bugs online or via OTAs, even without OTA, becomes a critical requirement to help achieve maximum efficiency in the vehicle development process. Yeah, and also as well in the project development, yeah, under the circumstance of the vehicle R&D requires so basically, yeah, we have to vehicle manufacturers have to manage the 4 even dozens of parties together to build new vehicles. Yeah, the software accounts even 80% of their R&D cycle times. And also, this is why we also need a software-defined vehicles architecture. So, in this case, yeah, basically we have to decouple the ECUs and the softwares and the hardwares. Every party is responsible for their own parts, and we can just like building blocks, and we integrate the OEMs integrate them together to and to managing them in one unified manners to defines the input and output. Yeah, so this is actually accelerates your the R&D cycling time. It reduces reduce the go-to-market time of new vehicles to like 1 or 2 years. This is one hidden reason why the Chinese EV brand is pouring new type of vehicles to the markets. Okay. Yeah. Another thing is actually will be despite from in contrast, unlike the previous days, the hardware first philosophy. So nowadays is a software first philosophy. The market's entrants are causing the traditional automakers to rethink their approach to software development within a software-driven ecosystems. So recognizing the limitation of relying in-house resources. Yeah, this is also why they wanted to introduce new vendors, new parties into the automotive industries. Yeah, rather than competing with these new players, many OEMs have taken their opportunities to work with newcomers like EMQ here, and take vendors to improve agility and scalability of the in-vehicle software development. Another trend is a robotaxi company or autopiloting. Yeah, I'm gonna take this part in a short time. Yeah, just to do a brief introduction here. So basically, we all know the Tesla FSD. Yeah, it allows level 4 autopiloting features. The reason Tesla could achieve such a huge goal, huge accomplishment is they are the first company to move from the case-driven to the data-driven car manufacturers. Yeah. Now, actually, Tesla is not a good it's not reasonable to treat Tesla as a car manufacturer. Actually, it is a data company. It collects data from vehicles to build data models on the cloud and then to continuously to evolve by the new data. Yeah, it just happened. The tool they use to collect data is a vehicle. That's all. Yeah, and by doing that, Tesla enables Tesla find out the past days we relies on a high definition map to do autopiloting, to do auto navigations. It's not basically it's not feasible. So they the first one to apply the transformer artificial intelligence to the autopiloting world. Yeah, the solution is called bird's eagle wheels. Yeah, they let and along with occupancy network, they build their own auto driving models based on such philosophies. Yeah. So the autonomous driving sensor solution and the computing platforms have become increasingly homogeneous, and the technology gap between the suppliers is narrowing. Yeah. So this reason because Tesla has made a model here, and a lot of OEMs follows up, and they all wanted to build their own data wheels, or we call it data closed loop platforms. So when OEMs require data runs through the entire life cycle, ranging from R&D, testing, and mass production and operations, and to maintenance, and to re-innovate. As the number of sensors in the intelligent connected vehicles swells, the amount of data generated by ADAS and the other domains in the vehicles also skyrocketing. Yeah, it's growing exponentially from gigabytes to terabytes even. Yeah, we imagine thousands of vehicles, aggregate data from thousands of vehicles to the clouds. A quick flow chart for you to understand how the data closed loop is pretty important in autopiloting. Yeah, we're gonna have a in current autopiloting features or autopiloting models. You have a lidars, you have radars, you have 4 or 5 cameras on the different angles of your vehicles, and they collect data in the spontaneous ways and aggregate them together to do the sensor fusions, let your vehicles recognize the context and the surrounding environment, and to and by mapping the different time frames to the different to the different positions of your videos, from your videos, to encode them so that the vehicles now can the models or inside of your vehicles can make right decisions to drive forward or drive left or right or stop. Yeah. And all of them requires a data channels between your vehicles and cloud. One more. So here's how our EMQ offering here. One part is, so we're offering a data closed loop for SDVs. So start from the data generations and along we built this platform along with our partners, and to provide a whole life cycle of data management from the data burst to the data persistence. Yeah. And the most interesting part between it is we also provide the high performance cross domain communications and streaming analysis and the ability to detect corner case without without the OTA process. Yeah, as you can see from the left part, I have emphasize the part offered by EMQ. So in vehicles, NanoQ acts as a in-vehicle data bus to do the cross-domain communications and data collections. Now we got the data, and now we need to put data to our streaming engines, which is eKyber. Now you can deploy your rules with eKyber, and we got the result and transfer those results to the clouds, but and with the powerful EMQS cluster sits on the cloud, we can deal with millions of vehicles, the data together, and to put the data to the auto driving models, so that you can easily manipulate your data while the database, or your data lake, to do verifications, retraining of your models. And once you got a new AI models, or you wanted to get find out a new flaws in your models, you can deploy a new rules or deploy a new data collection rules to the vehicles without with two rules easily. Don't need to update your the firmware in your ECUs. So here's a full picture of how our solution works. So we unify the real-time messaging and streaming in vehicles, between vehicles, and a vehicle to the cloud. Across the vehicle and the cloud, we converges hundreds of sensors and domains and ECUs, a dozen in the vehicles, to one connection, and consolidate this one connection by some new innovation like EMQ Quick, and by we can reuse these connections to reduce the network cost. I like applying new features to on it, like file transfers and topic prioritizations and congestion controls. So basically, we allow our solution allows OEM to extract the essence out from data by combining our edge data bus, our edge stream engines, by our edge cloud collaboration platforms, and along with EMQS clusters, to combining together with a time spatial context, then fuse all of these heterogeneous data in the cloud alone, also as well in the vehicle as well. Okay, here's one interesting case for you to get a deeper understand how it works. So you can imagine a case. You are a car manufacturers. Your customers, one time he was driving on the road, and enabling like auto steering features. The car is suddenly speed up to like 200 miles, which is definitely something wrong. And even though drivers hit the brake systems, hit the brake to stop cars, so it clearly there is something going wrong there. However, if you don't have channels to synchronize data from your vehicles to cloud, you don't know what is actually happening. You don't know what is going wrong for your models in your vehicles. Yeah. And if you keep pushing the whole scale of your data, the whole scope of your data from vehicle to cloud, the cost is unbearable. Yeah, it's barely impossible. Yeah, so it costs too much, and the network bandwidth is not tolerable. So we have to have a smart way to detect such a corner case happen, and then once it happened, it gives our signal here to our messaging broker and our messaging queue in the vehicles. And then it aggregates the data 5 minutes before or five minutes later together as one message or one or as a different as some files, compress them and cycle them to the cloud. And along with the metadata and the context data within it. So you know, once the file reaches the cloud, which reaches EMQX, now you know what's happening behind these files and what you're gonna do with these files. Yeah, this is really reduce the uh, uh, reduce the fault, reduce the diagnostic times, reduce the enables reduce the fault uh, reduce the time to find out the flows and to deal with the customer issues. Yeah. So in the whole life data cycles here, we provide you the cross-domain communications, the sensor fusion capabilities, the messaging convergence, the rolling update, the trigger to upload, and the vehicle. So in conclusion, yeah, we enabling the vehicle cloud collaborations to build data closed platforms. I guess that's all. Yeah. Sorry, I'm still not feel comfortable today. My essence might not be accurate here. Yeah, goes to you now, Manan.
Thanks a lot, Jalen. Thanks for giving us these insights. We'll quickly move on to the next session. And I would like to invite EMQ's technical evangelist Zibo to give us a demo upon the data integration in EMQX Cloud Serverless. Let me quickly also share my screen. Over to you, Zibo.
Okay. Yeah. Thanks. Hi everyone. Last time we demonstrated deploying an EMQ storage instance and connecting to the storage using MPTX and MPDSN is a MPD client tools. So today I will show you how to use the data integration in EMQ storage to forward the data from IoT device to Kafka or HTTP services. It's a very useful feature to link your IoT device to the end application in your server. The whole configuration process of data integration can be divided into 3 steps. The next page, please. Yes. So first, we need to create connectors. It's used to establish connection between inputs and external sources. Then we needed to create a rule, the rule device where the data comes from and how to process it. And finally, we needed to create an action that determines the final destination of the data returned by the rule. So we have a video to demonstrate how to create a Kafka integration. Now let's take a look. Yes,
Hi
please,
everyone,
video,
here
please.
is a demo of data integration. This demo includes 3 parts. Deploy a Kafka cluster, create data integration with Kafka in EMQ-X serverless, and verify the data integration by MQTT client. First, let's complete the first part, deploying a Kafka cluster in Confluent Cloud. After logging into the Confluent Cloud console, go to the Environments page. Choose an environment. You can just use the default here. Then click to create a cluster. Select the basic cluster. In this demo, this configuration is enough. Select the cloud provider and deployment region. Use the default configuration here and click Continue. Continue to use the default configuration and click Launch Cluster. Now we have a Kafka cluster. Next, we need to create an API key and a topic. The API key is used by EMQX to access the Kafka, and the topic will be used when EMQX publishes messages to a Kafka cluster. On the Cluster Overview page, go to the API Keys page. Select Global Access as scope for API key and click Next. We'll get a key and a secret. They are important. Click Download and continue to download the API key, API secret, and the address of the Bootstrap server, which is the entry point for EMQX to access the Kafka cluster. Then go to the Topics page. Click to create topic. Use the default values to create the topic. Skip creating the schema. We don't need a schema for this demo. Switch to the message browser. We will see that the topic is still empty. Now the Kafka cluster is ready. We'll head to part 2, create data integration with Kafka in EMQX serverless. Click on the card for the EMQX serverless deployment to go to the Details page. Go to the Data Integration page. Select Kafka Producer. Enter the Bootstrap server address of the Kafka cluster. Select Basic Auth. Enter the API key and the API secret. Enable TLS and disable TLS Verify. Test the connection to the Kafka cluster. If all is well, we will see the top right corner indicating that the connector is available. Then click Next to create the connector. Now the connector has been created. Let's continue to create rule. Using the default SQL, this SQL means to use all the messages matching the t/hash topic filter as the data source and get all the relevant fields such as topic, QoS, and the client ID of the message publisher. We can simulate the publishing of a message with SQL test. So we can see what this SQL will output. This is a very convenient feature as we can verify that the SQL written will work as expected. Once the test passes, click Next to create the rule. Now we need to specify a destination for the data returned by the rule. Select the Kafka connector we just created. Enter the name of the Kafka topic we created. Use the payload field returned by the rule as the message value. Click Confirm. Now the data integration with Kafka has been created. We'll move on to the last part. Test the integration using the MQTT client. Go to the Online Test page. In the newly opened tab, enter your username and password. Then click Connect. After the client connects, scroll down to the message publishing window. Change the publish topic to t/1 to match the topic filter in the SQL. Click to publish the message. Back to the Confluent Cloud Console's message browser. We'll see the message we just published displayed here. This means that the Kafka integration in EMQX is working as we expect.
Thanks, Zibo, for this demo. So following Zibo's insightful demo, what we have is Ivan joining us for products demo. Ivan leads our development team. We've seen Ivan multiple times. He's been a consistent throughout our EMQ office hours. So he leads our dev team and is the dev manager at EMQ. Ivan is based out of Stockholm and also holds almost 15 plus years of experience and led engineering for various IT companies and startups. So Ivan will be sharing the latest advancements and enhancements to our offerings. And over to you, Ivan. And there would be, I think, some features that Ivan also have recorded for us to showcase as well.
Thank you. Yeah, so version 5.7 is about to be released. We are wrapping up final rounds of testing and fixing the issues that we find. If things go as well as we hope, it should be released by end of this week. And the main highlight for this version is durable storage based on RocksDB is finally can be considered general availability. It will be available in both open source and enterprise editions. Also, there will be some differences in the capabilities, which will be announced in the release notes. And another highlight is now users can configure EMQX to make use of MQTT client attributes in authorization and authentication flows. And after this slide, we will see a short demo of this feature. And additionally, in the enterprise edition of 5.7.0, we will have schema validation. You can refer to EIP24 on our GitHub to take a look what it is. But in short, it will allow users to set up validation on messages passing through EMQX and actions, different actions depending if validation succeeded or not. Like you could drop messages which do not conform to your expectations and do not pass it to, do not route them to them. We will also add cluster linking. It's a smart way to connect to different MKX cluster for more robust cross-regional setup. We are adding batching to CSV in LSS3 connector, meaning that so we did have in LSS3 connector in version 5.6, but it was one message, one MQTT message, one file on S3. Which is not optimal since MQTT messages are usually very small and S3 prefers to work with large files. Now you can configure batching these messages in CSV form. And the last feature that I want to highlight is enhanced debugging and tracing in the rule engine, which should help people to maybe design rules in a safe way and troubleshoot existing ones if something goes wrong. And we'll have another demo of this one. And this is just to clarify that these are just highlights. Of course, it's going to be much more stuff added and more bug fixes. And in general, it's a quality of life improvement. Yep. Yeah, let's move on to the first demo. Yeah, so you see it's our cluster overview page. And we go to management, MQTT settings, and we have new area client attributes initialization. So we call this attribute product ID, and we tell MQX to extract it from MQTT user properties product ID field. Now let's configure it. And then we go to authorization, ACL file configuration. This is just, Mana, could you pause a little here? Yeah, so just for you to take a look, it's pretty much default except for the top section. This is so you see like allow all publish and up, and then we refer to client attributes product ID. So in this case, it means we allow any client to publish the topic up slash whatever, as long as this client has this product ID property match the topic name after the slash. And similar to they also can subscribe to corresponding down topic. And then we allow user admin to do anything on these topics. And then we deny everything else on this topic. And the rest is default, except the last line I changed from allow all, which is default, to deny all. Yeah, let's continue. Now we open MQTTX client. So this is a connection to it's a user admin, but nothing else. Then we connect first test client, which has no username password, but it has attribute product ID set to ABC. And it's subscribed to topic down ABC. And we have another client, also no username, but it has product ID attribute set to XYZ. So we try to post to down ABC topic and we get not authorized. So now we try to publish to, I'm trying to move it into to see the rules before my eyes. Now we try to publish the topic up/ABC as we should work, and it works. As it's supposed to, so we receive this message. And just to test it, we try up/X, and again we get not authorized. And the client XYZ cannot publish the topic up/X, but it can publish the topic XYZ, which is its product ID. Yeah, I think that's it for the first demo. And of course, before we go to the next one, I want to say that it's like there are more capabilities provided by this feature. I just showcase the simplest one to keep it short. Yeah, and the next one is I believe rule engine tracing, right? Yeah, let's go with this one. So this is that's wait, that's this one. Can we go to the next slide? No. No, it's no, yeah, okay. So I have already prepared connector beforehand. It's a PostgreSQL vanilla, nothing crazy. And then we create a rule out of it. It's everything is by default here, just a test rule. We create it, and then we enable test. And then you see new tab here, rule, test target rule, save, and then we run test. And then we input simulated data, which is I just use the defaults. And then we see test results. So this is a trace of rule execution, what it had and how it proceeded. And then we have what we'll enter. Yeah, could you pause here, Manan? Just take a look. Yeah, so you see the data for the PostgreSQL prepared statement. It's what data MKX will submit to Postgres in a formatted way. Like this, exactly these fields will go to Postgres. So if you don't see data that you expect in Postgres, it's a nice way to find out what went wrong. That this way you can see, okay, this is what we do and why it's not working, and you can manually use this data to troubleshoot. Yeah, please continue. And then we go to result, and you see the affected rows 1 exactly as you would expect. So it inserted 1 row. Yeah, and just to emphasize, so this feature is enterprise only, while the previous one is available in both editions. Yeah, that's it from me.
Thank you, Ivan, for this demo and the product updates. In our last office hour, we announced a special reward for the most, engaging developer in our session. So a $50 Amazon voucher was announced. So today we are excited to reveal the winner. This initiative is a part of our ongoing efforts to recognize and reward active participation within our community. So we'll continue to host such competitions and surveys to award our dedicated developers. So stay engaged, stay in touch, and keep participating because your voice and opinion does matter to us. And keep winning with EMQ. So the winner for the last office hours, APAC session is Ravi Sibbal. I think Ravi has joined in this session also. Ravi, if you can confirm in chat whether this is your email ID. After this session, I will connect to you on this email ID to provide you with the voucher. But congratulations, and please continue with your active participation as you've always been doing. So this, I think I can see one question that is for Jalen. This is the last session, which is the Q&A session as well. Oh, chat is not working. So, Ravi, your email ID was same, right? And any which ways, we have a question from Ravi also, Ravi itself. So, Jalen, this question is for you. That can you provide a list of hardware ECUs, domain controllers compatible and have executed using EMQ? If you can shed some light on it.
Yeah, actually, I believe the protocols or the name of the data bus is the more correct, accurate terms to describe it. No matter the different types of hardware ECUs or domain controllers, they basically communicate via like CAN bus, like a flex ray, like a link bus. Now we have a data proxy which could read from data from the CAN bus and convert them to MQTT and communicate with EMQS. And for those ECUs and DCUs communicate via the Ethernet, they usually use like protocols like some IP or DDS. Yeah. Now we have a standard data proxies in NanoQs allows you to convert the protocols from the DDS and some IP to MQTT as well. And it is also has an open source version in NanoQ. Yeah, you're welcome to try it. If you want to have a more detailed information, you can contact our like a business department, yeah, for detailed menus, yeah.
Got it. I think we've over exceeded the time as well, but thank you everyone. Thank you our panelists for joining us at today's EMQ's Office Hours event. Your presence and engagement definitely made this event truly remarkable. So we'll see you next time. And till then, stay safe, stay tuned in. All right, bye bye. Have a good day ahead, everyone. Thanks for joining in.